An object with weight 1 kg drop from a static point into the pool after t seconds. So the velocity is v. Given the resistance of the pool is 5 Newton. Okay, so normally dE differential equation, they will give you differentiate the changes of velocity respect to time. The given here is your gravity g minus 5v. Okay, so where g is a constant, so you know this is constant. This is constant, variable kamu v dengan t saja, so you have one variable here. Alright, so when you get dE, you have to identify what's your variable. If you have one variable means you can do separable. Ni satu factor v saja. T tak wujud kan? So T tak wujud, biasanya boleh buat separable. Okay? So express, carilah V in term of T, apa-apa jawapan T. So take out your story timeline. Your variable T and V. So solve this first, question A. dV dt g minus 5v. So as I said just now, this is your factor v. Your t means tak adalah satu lah. Separable method. Factor v pindah ke sebelah kiri. So this is v punya bahagian. dt sebelah kanan. Cara separable. Kita ada dua method. Satu separable, lagi satu IR. Kalau kita boleh factorize macam ni, so separable. Kamu boleh nampak, oh ni factor V. Oh, ni T tak ada, so ni separable. Kalau variable kamu, contohnya V dengan T, dia campur-campur, dia ada equation, dia terikat. Tepi-tepi kamu tak boleh nak factorize. So kita pilih method yang kedua, IR. Nah, itu simplest lah. Ada step dia satu-satu ya. Okay, so we come back here. So integrate both sides. So look at the V. Your variable here V. This is linear. 5V plus G. So this is linear. So we can straight away ln G minus 5V. Don't forget your constant here negative 5. So for the right hand side, integrate T. So 1T tambah C. So what is your story timeline here? Just now, what's your story timeline? You are dropping from a static point. So starting of the story, when you want to drop, is a starting point. So its velocity was 0. Faham? Initial velocity is 0 because static point, dia tak gerak. Baru kamu jatuhkan dia, baru dia ada velocity v, kan? Betul? So starting of the time 0, so velocity v. Okay, we simplify first. Simplify until we get general solution. Then only we substitute to find particular solution. So jangan substitute sini ya. Jangan substitute sini sebab sini belum lagi cantik equation dia. Ada ln lagi, ada 5 lagi, kena simplify. So simplify here. Times negative 5t times 5. So I just limit it at constant c. Boleh? Constant c dengan 5 ganda constant c lah, constant lah, still constant. Then unlock. So don't confuse with the modulus with the ln ya. This modulus hanya untuk make sure g minus v ni positif. So bila kita unlock, kita buanglah sekali dengan positif ini. Ya, faham? Jangan ingat dia ini modulus function. Tak, ini ln function. So e to the power everything. So e negative 5t EC maksudnya jarak. Pecahkan power dia hasil jarak. So I make it a constant A. What we need here is V. dV dt maksudnya belah kiri V, belah kanan T semua. Then simplify. minus G. So V here bahagi negatif 5. Negatif, negatif, positif. Then we can start substitute the first initial value. We substitute t equals to 0, v equals to 0. Plus g over 5. So what do you need to find out here? G or A? Find out A. Find out A. G is given. Is a constant. G adalah constant yang diberi daripada soalan. So kita tak payah pergi cari G. Kita kena cari constant yang kamu nak. Constant yang kita nak cari itu C. So daripada sini C ni dah jadi A. So saya nak cari A lah. Habis. E kosong. E kosong bukan kosong ya. E kosong 1. So negative I mode aku become positive. So A is gravity constant. Betul? Then only our solution is particular solution. Tadi ini general saja. So saya substitute G over negative 5. G over negative 5. Then E negative 5t plus G over 5. So I can notice that G over 5 I can factorize negative E 5t plus 1. So this is our question A. Find the solution V in terms of t. Okay. Question B. Find the velocity when t going infinity. Alright. So concept of calculation on infinity. When t is infinity, what happened to our V? This is question B. So to evaluate infinity dengan baik, ni negatif ni kita letak balik tempat dia yang asal, iaitu 1 per E 5 times infinity. Boleh? Kuasa negatif tu kita letak balik di tempat penyebut, barulah kamu boleh kira infinity tu dengan jelas. E5 times infinity. So calculate one by one. 5 darab infinity. 5 darab infinity. Infinity. E kuasa infinity. Ni 5 darab benda besar-besar, nilai besar-besar. Masih lagi nilai besar-besar, betul? E berkuasa nilai besar-besar. So, bahagian ni akan jadi nilai besar-besar. So that's why I asked you to put back originally dia punya position kat mana. Tetapi 1 over infinity, 1 bahagi benda nilai yang besar-besar, you can test with your calculator. 1 divided by 1 billion, 100 billion, what can you get? Almost 0, right? Almost 0, 0.000 something, correct? So you'll get 0 plus 1. So finally we can approximate our V is G over 5. So when t approximate infinity, conclusion, V approximate G over 5 and S minus 1. Done? Done here? Question C. Show that the distance traveled by the object in 6 seconds is about. Okay, so question C. Question C, they ask you to show that distance S. In your physics, you denote the distance as S, right? Ataupun D, betul tak? 29/25. Or I put D. When T is equal to 6. So from velocity, how do we get distance? Then have to recall back your physics concept or your maths concept. From distance or displacement, the changes of distance is velocity, correct? Yes or not? Velocity is distance over time, means the changes of distance over time, correct? So if we want to find back distance, yes, in the grid. Changes, what's your definition? Rate of change of distance is velocity. Velocity, rate of change of distance. So when we write in mathematics term, rate of change dx dt, so how do we get S? In the grid. In the grid respect to time. So when we integrate respect to time, and integrate and differentiation cancel each other, that will be your distance. Alright. From distance, you differentiate, you get velocity. Rate of change of distance, you get velocity. So from velocity to get back equation of distance, yes, in the grid. Actually, this one can be applied, velocity to acceleration. Yes, the rate of change of velocity is acceleration, differentiate. When you want from acceleration, get back velocity in the grid. So today's questions is involve distance and velocity only. So it might be extend velocity and acceleration later. Faham? So distance differentiate, you get velocity. Velocity differentiate, you get acceleration. Reverse back the process, you can get back the distance. Okay. So you want how many minutes? 6 minutes, means from beginning 0 until 6 in order to find distance. We're going to integrate 0 until 6 because it said in the time of 6 seconds. So integrate this one. Where is our equation? Our equation of velocity, g/5 negative 5t plus 1. Then respect to time. Boleh? Faham ke formula ni? Integrate equation V. Integrate equation V, kita dapat integrate velocity, kita dapat distance. Okay. Because it said daripada dalam masa 6 minit, maksudnya daripada T0 until T6. Okay, so integrate this. Identify your constant. Your variable is T, right? So constant g/5 we factorize out. Supaya tak pening lah, you are going to integrate respect to T. So integrate E, salin balik, bahagi dengan negatif 5, betul. Integrate exponential, salin balik, bahagi balik, kuasa dia 5. And then integrate 1, dapat T. Upper limit 6, lower limit 0. So negative simplify, we just substitute upper limit, which is 6 minus lower limit 0. So, apakah nilai di sini? Dapat berapa? Dapat tak? G over 5. So this one is? This one is? This one is 6. Already plus 6 or what? Bahagian sini 6. Ini 6. 6 tambah 6. Total sini 6. Sini? Kosong. Mana mungkin kosong? 1 over 5. This one total 1 over 5, right? Okay, so 6 minus 1 over 5, then times 5. Is it 29 over 25? Is it 29 over 25 G? Is it? Yes. It's just G. So distance meter show